Our dear students, today we are solving ISI JRF Economics 2024. So here is the second question. So consider competitive profit maximizing farm producing a single output in the production function x and y, thus p and pv respective input level. Px is the output, so that the marginal increase in pb from an initial situation must have an increase in the farm's output. So marginal increase in pa in this situation where the profit maximizing input combination involves positive amount of both the inputs. So the profit maximization problem here is you have to max out a b pi px of x, pa of a and pb of b, subject to this x a plus b gamma b square. Okay, so taking the derivative of the profit function with respect to b, so d pi by db is px gamma alpha plus beta gamma minus 1 pb, given that gamma belongs to 0 comma 1 a plus b gamma minus 1. So therefore d pi by db is positive if px is pb by gamma into a plus b all to the power gamma minus 1, given that the farm's profit maximizing input combination involves positive amounts of both inputs, a greater than 0 and b greater than 0, these two, and a plus b gamma minus 1 is also positive. So therefore this px thing is pb gamma a plus b gamma minus 1 is a marginal increase in pb, increases the farm's output. Okay, so this is the first part. Second part, now consider the farm's cost minimization problem subject to a exogenous output target x0. So assume that as before, an initial equilibrium in the farm's profit maximization input combination involves the positive amounts of both inputs. Prove that the marginal increase in the farm's output target from such an initial equilibrium reduces this cost and minimizing the level of b. Okay, so in this case we have to make a slight changes. So this is the thing over here. So the farm's cost minimization problem here, target, so minimization of a comma b with respect to c, pa of a, pb of b, subject to x b square and x equal to x0. So this is the target constant. So the Lagrangian formation of a, b and this will be pa of a, pb of b, lambda b square x0. So the first order conditions are del L del A, pa lambda b a plus b to b lambda. So del L del b will be lambda gamma a plus b whole to the power gamma minus 1 to lambda b equal to 0, and del L del lambda is this equal to 0. So from the first order condition we get pa and then pb and given the output target constant we have this substituting this into the pb, we get that pb equal to b square x0 gamma minus 1 to lambda b. What a long calculation here, and just we are about to end 4 lambda b so to show that the marginal increase in the farm's output target from an initial equilibrium, we now have to just differentiate this dpb with respect to dx0. So this is v square minus 2. So the derivative is negative since gamma minus 1 is negative, as it lies between 0 to 1. So b square plus x to the power 0 gamma minus 2 is always positive. So therefore a marginal increase in the farm's output target form an initial equilibrium where the farm's profit maximizing input combination involves positive amounts of both inputs must be reduced its cost minimization level of P. And that's the answer to this question.